Hello, boys and girls. This is your captain. How are you guys doing? Thank you for your patience. Yes, we had some issue. Lag was there. So I'm recording the session. I hope you like it. All right. So let's start the session. Yes, my name is Harsh Maheshwari. For those who are joining in for the very first time, I am from NIT Varangal. I have been teaching from last more than 3 years actually. And yes, I believe in one thing that jo karo, maze se karo, otherwise karo hi mat. Dil laga ke karo, and the result would be awesome. Always awesome. Keep that in mind. Yes, this is our weekly schedule. Please make sure you take a screenshot so that you would be knowing when is your favorite teacher coming online to teach you. Beautiful. All right, moving on. Yes, one more thing, a quick information. We are having, this program for you, that is Vedantu JEE 2021 program. We are giving you live lectures from the best faculties in the entire India. Similarly, you are getting, assignments. You are getting doubt clearance, instant doubt clearance. You will be getting. You will be getting recordings. You can watch replays like n number of times because in your offline institutes, if you miss a lecture, there is no recording. You can't get class notes. You will not get anything. But here we are giving you the option of recording and going for replays. You can replay it n number of times. And see, more important, we are giving you analysis of the previous year exams so that you can always lift yourself up, lift your knowledge up. And yes, how to get it? Just enroll. Just link is there in the description box. Click on that link and enroll for free. All right, moving on, boys and girls. What we are going to do today, we are going to learn about electrochemistry. I'm going to introduce to you that what is electrochemistry and what types of cells are there. One by one we are going to discuss in detail, and today we are going to go for galvanic cell. Just a quick information, we are going to learn about galvanic cell. All right बच्चों, so start करते हैं class. So start करते हुए I'm saying I'm welcoming each and every one of you. And yes, if you haven't liked the video yet, please make sure you like it, subscribe to our channel, and yes, hit the bell icon so you will be notified when I'm coming live to teach you guys. All right, स्टार्टिंग अब स्टार्ट करते हैं, चलो ठीक है. ऑलराइट, तो है क्या ये इलेक्ट्रोकेमिस्ट्री? व्हाट इज इलेक्ट्रोकेमिस्ट्री? मैं बुकिश डेफिनेशन को हटा के एक सिंपल डेफिनेशन देता हूँ. देखो, ये एक ऐसी इलेक्ट्रोकेमिस्ट्री, इट इज अ रिलेशनशिप. इट डील्स विद द रिलेशनशिप between electrical energy and chemical reaction. What is the relation they are having? This particular chapter would be dealing all about that. क्या समझाना चाह रहा हूँ? देखो, electrical sources, you see electricity around me, you see light. Electrical energy can be created by n number of sources. For example, hydropower plants, solar power plants, nuclear power plants, coal based power plants. N number of ways are there. But if I talk about all these ways, for example, hydropower or hydro energy, what we are doing, we are bomb blasting water, or we are making sure water is hitting a particular shaft. That shaft is rotating, and that shaft is actually creating mechanical energy, which is converting into electrical energy. That is what we are doing, right? And similarly, in your coal based power plants, what we are doing, we are boiling up water, creating steam. That steam is passed through turbines, and again mechanical energy is giving you electrical energy. But beta, in this particular chapter, we are going to learn a thing called electrochemical cell. In electrochemical cell, this dependency on the thing called mechanical aspect, the dependency on any kind of mechanical aspect is no longer there. We are eliminating that, and we are actually creating a cell called as electrochemical cell. It does not require any kind of shaft, any kind of turbine. It doesn't need that. ठीक है, काफी अमेजिंग है, यही पढ़ने वाले हैं हम. तो ये इलेक्ट्रोकेमिकल सेल बच्चा दो तरह का होता है, गैल्वेनिक सेल एंड इलेक्ट्रोलिटिक सेल. गैल्वेनिक सेल को हम वोल्टाइक सेल भी बोलते हैं. इट इज आल्सो कॉल्ड एज वोल्टाइक सेल. इन सिंपल वर्ड्स, इफ आई हैव टू से, इतना सब कुछ पढ़ने की डरने की जरूरत नहीं है. देखो, गैल्वेनिक सेल क्या है? Galvanic cell, what happens here, we convert your chemical energy, we convert chemical energy or chemical reactions. Chemical reaction gives us electricity, electrical energy. ये electrical energy में से बदल देता है. From what we are doing, we are creating electricity by the virtue of or by the help of chemical reactions. Whereas electrolytic cell, we do the reverse. We actually create, a chemical reaction is happening when we pass electricity to it, or when electricity is passed, you will get a chemical reaction. ठीक है, so are driven by external source of electrical energy as you guys can see. ठीक है, don't worry about this, ये आगे जाके अभी और हम clear कर लेंगे. ठीक है, moving on. What is now, if I have to again define what is electrochemical cell, it is a device that converts chemical energy into electrical energy or vice versa. I hope it is clear. ये बात समझ आ गई है. और हमारे को दो तरह के सेल पढ़ने हैं, galvanic cell and electrolytic cell. We are going to discuss in detail first of all about galvanic cell. We are going to learn it, understand it, and let's start our class on it. ठीक है, इसके ऊपर बात करते हैं. Galvanic cell, beautiful cell. We are getting electricity out of a chemical reaction. From a chemical reaction, we are getting electricity. All right, देखते हैं क्या होता है. तो कुछ ऐसा सेटअप है. This is the setup. घबराओ मत, देखो मतलब देखकर घबराना मत. I'll explain each and every bit. Here we require three things. हमारे को तीन चीजें चाहिए बच्चों. We require oxidation, oxidation half cell, oxidation half cell. मैं बताऊंगा क्या क्या है. Second thing which we require to create a galvanic cell is reduction half cell. Reduction half cell. And third, but your favorite, is your, what we require is a salt bridge. ये सारी चीजें हमें चाहिए. तीन चीजें अगर मैंने ये सेटअप कर लिया, if I am able to procure these three things and arrange them in a proper manner, I can create, I can create electricity from chemical reaction. I hope it is clear. ठीक है, अब ये हो कैसे रहा है, देखो बल्ब जल रहा है. अब ये दिमाग में भी बत्ती जलाते हैं हम. Let's light up the bulbs in our minds. Let's start the session and understand what is happening. देखो जरा. तो galvanic cell ऐसा आपको बुक में मिलेगा. This side is cathode. This side is your anode. I'll explain everything in detail one by one. ठीक है. So let's start. So I told you components of galvanic cell. There are three components. First one, oxidation half cell, reduction half cell, and salt bridge. Third one is being the salt bridge. Beta, what is oxidation half cell? नाम से clear है. You are creating something in which oxidation is happening. What will you see, boys and girls? What will you see? Check this out. You will take, I'm explaining oxidation half cell. What you are going to do, beta? You are going to take a metal, a container in which you are going to dip a metal M in its own solution. Let's say M plus N aqueous, right? So you're going to take your metal, dip it in its own solution, and it will undergo oxidation. What is happening? This metal ion is converting into M plus N ion. Check this out. This process is called as oxidation. इसको क्या बोला जाता है? This is called as oxidation. Your metal is getting converted into, sorry, my mistake, is getting converted into metal ion. सही बात, क्लियर है? बड़ा सिंपल सा बात बोला मैंने. आई होप इट इज क्लियर. योर मेटल इज गेटिंग कन्वर्टेड इनटू मेटल आयन. अब मुझे एक बात बताना, बड़ी इंपॉर्टेंट बात. डू नॉट वरी अबाउट द रिप्रेजेंटेशन. चेक दिस आउट. टेल मी अबाउट वन थिंग. व्हाट विल हैपन हियर बेटा? व्हेन दिस प्रोसेस विल कीप ऑन हैपनिंग, positive charge would be more in the solution because metal is getting converted into M plus N ion. So positive charge would be created in the solution. Similarly, the positive charge on the rod would be relatively less. So there is a charge difference between the two surfaces. And in physics, you also study whenever there is a charge difference between the two surfaces, potential is developed. This developed potential, whatever the potential is developed, this developed potential is called as oxidation potential. Okay? This is called as oxidation potential. And how do I represent it? I represent it by writing a capital E. And I am representing, देखो, that metal, this is our metal, मैं यहाँ लिखता हूँ, that E, that metal has been converted into M plus ion. This means this is called as oxidation potential. What I say, I call it as OP, oxidation potential. That your metal is getting converted into metal plus ion, and there was a potential developed due to the charge difference, and this particular thing is called as oxidation potential. Okay? Acha. Now some of you say, sir, what is happening? This vertical line is to denote that there is a phase difference. This is the, this is the way we represent a half cell where oxidation is happening. You will put a line in between, and this line, what is the point of it? This vertical line, it explains that there is a phase difference, or metal is in solid state, and your ion of course is in aqueous state. I hope it is clear. ऐसे ही एक चीज होती है, जरा मेरी बात सुनना। आप अलग अलग मेटल्स के लिए एक सिंपल एक जनरलाइजेशन कर रहे हैं। व्हाट इज हैपनिंग, व्हाट इज ऑस्मोटिक प्रेशर? It is the tendency of the metal ion to get converted into metal. This is called as osmotic pressure. What is solution pressure? Tendency of the metal to get converted into metal ion. So two things are there: osmotic pressure, solution pressure. Same whatever the setup I have created there. I'm dipping your metal in its own solution, putting a external wire. Now two things can happen: whether it can give you M plus ion, or whether it can give you the ions will start depositing at this particular metal rod, right? If osmotic pressure I talk about, it is tendency of the metal to give you metal ion, and if I talk about solution pressure, to get deposit, I just said something wrong. Osmotic pressure is what? Tendency of the metal ion to get deposited as metal, and solution pressure is what? Tendency of the metal to get converted into metal ion. ठीक है, अब जरा ध्यान से सुनना. If I am talking about oxidation potential, if I am talking about oxidation potential, अभी अभी हमने potential, अभी अभी we have just the representation is E, M is getting converted into M plus N ion. I hope it is clear. This is solid, this is aqueous. ठीक है, अभी अभी just अभी अभी करा है. So beta, what will be more here? Osmotic pressure, because oxidation हो रहा है. Oxidation has been happening. So what shall I say? Osmotic pressure is more. Osmotic pressure is more, or solution pressure is more. Sometimes they can ask you this also. ठीक है, which is more, osmotic pressure or solution pressure? And it is quite evident solution pressure is more here. ठीक है, because oxidation is happening. Correct? यही चीज यहाँ समझाइए. Similarly, I rather not use these two terms. I'll call it simple. Similarly, if you are osmotic, if I write solution pressure again, and I write osmotic pressure. So what will be more here? If I talk about if what will happen if osmotic pressure would be more, you will say reduction is happening. Means what is happening? The metal ion is getting deposited on the metal. So next thing which we are going to study is what reduction potential stand or reduction half cell. ठीक है, अच्छा एक चीज होती है स्टैंडर्ड स्टेट, जरा ध्यान से सुनना. स्टैंडर्ड स्टेट क्या होता है? When pressure is 1 bar, concentration is 1 molar, temperature could be any, but generally we take 25 degrees Celsius. If you are creating your oxidation half cell, or if you are creating your half cell carrying out these conditions properly or maintaining these conditions properly, then it will become standard oxidation potential. And what is the difference? You will bring a naught. You will just, instead of E, it will become what? It will become E naught. E naught is an indicator that you have created a standard half cell or standard half cell you have created, and the potential developed out of that particular oxidation half cell would be called as standard oxidation potential. In short, we call it as SOP, and right now we call it as OP. So OP will become SOP when pressure would be 1 bar, temperature could be any, but usually we take 25 degrees Celsius, and concentration is 1 molar. So oxidation potential will become equal to SOP, standard oxidation potential. I hope it is clear. Next one, your favorite, reduction half cell, second component of galvanic cell. Very, very easy. What is happening here? Metal is getting reduced, right? Metal ion is getting reduced, right? Reduction is happening here. Your osmotic pressure is more here. Osmotic pressure is more than solution pressure. I hope we have just now discovered, talked about it. What am I saying? Now, pay full attention. So, what will happen? Your metal ion will get deposited on the your particular metal rod, and this process is reduction. And in this reduction, again, what is the representation? Check this out. What is happening? M plus N. Your aqueous ion is getting deposited into solid form. जो हो रहा है वही लिख रहा हूँ. So this is called as reduction potential, RP. In short, we call it as RP, reduction potential. ठीक है, हम इसे reduction potential बोलते हैं. And again, if we carry out all these things at a particular, at particular pressure, that is 1 bar, concentration 1 molar, and temperature usually 25 degrees Celsius, then we call it as standard reduction potential. It is called as SRP now. Acha, same logic here, beta. What will happen? Check this out. When metal ion will start getting deposited on the metal, right, on the metal rod, what will happen? There will be difference in charge again. Solution is becoming less and less positive because the metal ion is getting deposited on the metal rod. This charge difference will create potential, and this potential is called as reduction potential. If it is at standard condition, we will call it as standard reduction potential. I hope it is clear. ये समझ आ गया है. आगे बढ़ूंगा. Now the third and the last component of our galvanic cell is salt bridge. Salt bridge होता है. Salt bridge एक inverted U tube है. It is an inverted U tube filled with filled with salt in agar solution. In agar agar solution. Basically एक gel based solution है. Agar is coming from algae, and it is derived from algae, and it makes a viscous solution. What I do, I'll dissolve my NaCl, KCl, or NaNO3, any salt, pick whatever you like. I'm taking NaCl, I'll dissolve it in agar solution. A thick jelly is formed, inverted U tube. You can see this is called a salt bridge, and you at the very end you put cotton plugs so that the paste will not come out of that particular salt bridge, ठीक है, or from the particular setup. It is an inverted U tube. ये inverted U tube है जिसमें आप salt डालते हो, and you make sure it is in a form of a thick paste, viscous thick paste, so that it doesn't flow out because you have to put it against the gravity, right? आप चाहते हो कि ये अंदर ही रहे, gravity से बाहर ना आ जाए. So you make sure the liquid you are using is agar solution. I hope it is clear. ठीक है, अब मैं इसका logic समझाऊंगा, so stay connected. All right. Now, why we are doing this, right? This salt bridge actually, what is the utility? It connects the two half shell, completes the internal circuit. बहुत important बात बोली है मैंने. It completes the internal circuit. What does it mean? Pay full attention. Pay full attention. ध्यान देना. देखो, अब मैं क्या समझाना चाह रहा हूँ, जरा ध्यान दीजिएगा, बहुत important है. If I talk about electricity production or electrical conductivity, you guys know that metals conduct electricity by the flow of electron, and solution conduct electricity by the flow of ions, right? And in this setup, what I have just now shown, that you will create an oxidation half cell from where what is happening? Electrons would be given out. Similarly, just now we have seen reduction half cell. What is happening here? Same setup. It is accepting electrons, right? And it is undergoing reduction. Same setup, same. So electrons are moving, but in the solution, ions are not flowing. There is not a flow of ion. To maintain this internal circuit or to complete this internal circuit, we add this particular salt bridge. It completes the internal circuit so that electricity can be generated, electricity can be produced. I hope you understand the point. ये internal circuit को complete करता है, connect the two half cell. अभी भी और clear करता हूँ, अभी भी pay full attention. ठीक है, हमें इतना समझ आया. ये नोट को एक सेकंड बाद पढ़ाऊंगा. I'll talk about it after 1 second. हाँ, अब जरा ध्यान देना. What you can tell me, what will happen if there is no salt bridge? ये point आपको काफी ज़्यादा information देगा. It is going to give you a lot many information. Check this out. Check this out. What is gonna happen? So I will create. I have created here. और मैं इसको ऐसे ही लिखता हूँ. You guys understood the setup. Setup was just like this. I'm connecting the two half cells by an external. Here, oxidation has happened, and here reduction has happened, and electrons are moving here and there. All right, so external circuit is complete. But beta, what will happen after some time? Check this out. It is very, very important. If there is no salt bridge, I'm just adding an inverted U tube. You would say, sir, what if I add only a U tube so that ions flow can happen? Let's see what will happen. So if you will create an inverted U tube, just like this, देखो जरा क्या होगा. अब जरा ध्यान से सुनना, बहुत इंपॉर्टेंट है, जरा ध्यान से सुनेंगे सारे. When I talk about oxidation half cell, what was happening here, boys and girls? In the solution, more and more positive charge was coming, correct? Metal was giving you M plus N ion. So this solution will become more and more positive, more and more positive. And similarly, if I talk about reduction half cell, what was happening? Metal plus N or M plus ion is getting converted into metal, correct? So it is becoming more and more negative, more and more negative. If you have no salt bridge, beta, if you have no salt bridge, ध्यान से सुनना और सारी चीजें clear होती रहेंगी. What will happen? These charges will come up in the salt bridge. There is no salt in the salt bridge. There is no agar, NaCl dissolved in agar paste. Agar aisa na hua, so these charges of the solution will come up inside this, glass tube, and they will meet at a particular point. Let's say they are meeting at this particular point. This particular point is called as liquid-liquid junction potential. This will actually create a potential called as liquid-liquid junction potential, and it is very harmful for the cell. It is going to create a potential which is in opposite direction of the cell potential. For example, you want to create, for example, your cell is giving 5 voltage of electricity, or 5 volts. It is producing 5 volts, right? Basically, we are getting electricity, and the potential reading was 5 volts. If liquid-liquid junction potential will start coming, liquid-liquid junction potential, what will happen, बच्चा लोग क्या होगा? It is in reverse direction. Let's say 5 voltage you are creating from your proper galvanic cell, and it happens it is happening in that particular cell that liquid junction potential was created. So what will happen, बच्चा लोग? And it is always in opposite direction. Let's say it is -1 volt, of -1 volt. So total cell potential will decrease. Initially it was giving 5 volts, but there was a liquid junction potential which is in opposite direction to your galvanic cell. Let's say it is of -1, so total potential will become 4 volt. I hope the point is clear. So it is very bad. That's why we add salt in the form of, we dissolve the salt in agar paste. I'll talk about it in much more detail. Just give me 1 more minute. So to eliminate liquid junction potential, we use salt bridge, so that there will be no unwanted potential development in the galvanic cell. One third and most important reason. ठीक है बच्चों, आगे बढ़ूंगा. अब हमने तीनों कंपोनेंट पढ़ लिए. How do we arrange them? So you have your anode right side. वैसे actually anode is mostly on the left side and cathode is on the right side. This description is very nice, so that's why I have taken up this picture. Otherwise, anode is on the left side and cathode is on the right side. I tell you why I am calling it as anode. Check this out. What is happening here, beta? I have taken zinc and copper. I have taken zinc and copper. Zinc is more reactive. Beta, zinc is more reactive as compared to copper. What does it mean? It can form electron. It can give electrons very easily. Reactive means it can give electrons very easily, whereas copper has a tendency to accept electron. ठीक है? Accept electron. अच्छा, अब आप बोलोगे सर, how do you know? In the coming classes, I will give you an electrochemical series which we have to see, and no need to mug it up. Data would always be given for that. कभी रटने की जरूरत नहीं पड़ेगी. Right now I am telling you, so you have to believe me that zinc is more reactive than copper. ठीक है, इतना हमें पता लग गया. So it means it has a tendency to give electron. Means it can undergo oxidation, and copper will undergo reduction. तो ये information बड़ा important था. So what will happen, beta? This zinc will start converting into zinc plus 2 ion, है ना? And electrons would be released. These electrons, because of the external circuit, it will go off. And since oxidation is happening here, we call this end as anode. What is most important here, since electrons are produced and transferred by the external wire, anode is of negative charge. ये बहुत important है ये point. I am again repeating, zinc is converting into zinc plus 2 ion, है ना? So what about the electrons? These electrons are making the rod negative, and this is going via external circuit, right? That's why anode will occupy negative charge on it. Anode oxidation is happening, but it is getting negative charge on it. Similarly, this electron will go, and it will reach copper. Copper has a tendency to undergo reduction, so it will start, the copper plus 2 from the solution will start depositing on the metal rod. ये metal rod पे deposit होने लग जाएगा, because electrons it will see, it will go crazy, it will start depositing, and this process is called as reduction, and we call this as cathode. And of course, since copper plus 2 ions are attracted here, this charge has to be, it is positive charge is coming. Why positive charge is coming? There must be a I'm really sorry. The negative, why negative charge is coming towards this side? There must be positive, and there must be positive charge. So this copper plus ion is coming over here, and cathode gets a positive charge on it. ये बहुत इंपॉर्टेंट है, नेगेटिव पॉजिटिव. अच्छा, तो ये होता रहेगा. अब इंटरनल सर्किट को कंप्लीट करने के लिए वी रिक्वायर अ सॉल्ट ब्रिज. बेटा मैंने अभी बताया, इन एनोड व्हाट विल हैपन, your positive charge will keep on increasing. So what will happen, from the salt bridge you will take a salt, and salt contains cation and anion, both positive and negative part. So the negative part will come and it will neutralize the excess charge, so it maintains the electrical neutrality also. This is point number 4. Salt bridge is maintaining electrical neutrality also, so that the cell doesn't short circuit ना हो यहाँ पर, ठीक है. So it will neutralize all the positive charge, and here negative charge is formed in excess because your copper plus 2 is getting deposited, right? Or yes or no, it is getting deposited at the metal rod. So as a result, your negative charge is more. So from the salt bridge, Na plus ion will come and it will dissolve and it will neutralize this excess of charge. I hope the point is clear. That's the purpose of salt bridge. So what are the points? It connects the two half cells, maintains or maintains or completes internal circuit, maintains electrical neutrality, just आपको बताया. Similarly, last but not least, eliminates liquid junction potential. So चार यूज होते हैं, चारों के चारों मैंने बता दिए. एक और चीज मुझे बताओ क्विकली, यू गाइज हैव टू टेल मी इन द कमेंट बॉक्स कि ये बात सही है या नहीं. आई एम आस्किंग यू ऑल, यू हैव टू लेट मी नो कि हाँ सर ये बात करेक्ट थी, आई अंडरस्टूड द पॉइंट. यू हैव टू लेट मी नो इन द चैट बॉक्स, ठीक है, in the comment box of course, है ना. देखो, since zinc is undergoing oxidation, this metal rod, the mass of, can I say, the mass of zinc rod would decrease as time will proceed, as time will, this reaction, if we are allowing this reaction to happen, zinc will become zinc plus 2, right? It will come in the solution. So mass of metal rod will decrease, concentration of zinc plus 2 ion will increase, correct? Similarly, if I talk about your cathode or reduction half cell, what is happening here? Very, very easy. You can see concentration of copper plus 2 ion decreases, but the mass of copper rod increases. Mass of copper rod increases. I hope you guys are understanding. ठीक है, अब जरा सुनना. ये सब कुछ हो गया, तो अब जरा रिएक्शंस देखते हैं. At anode, anode means हमेशा क्या होगा? Oxidation. What was the terminal sign or the terminal, अगर मैं पूछूं, terminal sign here is negative. This is a very important point about anode. Anode here is negative, ठीक है? It is giving you plus 2 charge. If you talk about cathode, cathode where reduction is happening, 2 electrons it is accepting, copper plus 2 ion is accepting 2 electrons to give you copper, and it is depositing at the metal rod or copper rod. If you balance this reaction, you have to balance in such a manner that all the electrons get cancelled. मतलब दो इलेक्ट्रॉन दोनों तरफ आ रहे हैं ना, I have to make sure the electrons are equal, balance it. The net cell reaction is this. You can check this out. Copper is undergoing reduction, that's what we have just seen. Zinc is undergoing oxidation, that's what we have just seen, correct? Number of electrons involved in this process is 2. You have to make sure that electrons involvement is same. अगर यहाँ पर 2 है तो इधर भी 2 ही होना चाहिए. अगर यहाँ पे 5 होता तो we had to make sure the 5, there are also 5 electrons, ठीक है. Overall process में number of electrons should get cancelled. So what is the number of number of electrons involved in this reaction? 2 electrons are involved in this reaction. I hope the point is clear. अब हम देखेंगे how do I also find the cell potential. अभी देखा मैंने half cell potential, reduction, oxidation half cell potential, reduction half cell potential. Now when you are combining and creating a new cell, what would be the potential? So I hope you guys are understanding. Please let me know in the chat box कि हाँ सर समझ आ रहा है, सेशन बहुत अच्छा लग रहा है. Please do let me know once I have given you the recording. I have recorded the session. I'll let me know in the chat box कि सर समझ आया, मजा आया, so that second class would be much more fun. अच्छा जी, आगे बढ़ेंगे. हाँ जी. So check this out. This is our net cell reaction. Now I'm going to tell you how to represent the cell. Cell को represent कैसे करना है. तो यहाँ पे ये net cell reaction है. This was our net cell reaction. ध्यान दीजिएगा. एक चीज होती है reaction question Q. It is equal to the concentration of the product side, of obviously of course aqueous side of aqueous ions, divided by concentration of the reactant ions, right? And activity of solid is taken as 1, right? तो आपको पता ही है reaction question यहाँ लिखूंगा कैसे आएगा. We have learned it in 11th class. Same बिल्कुल same है. तो Q would be equal to what? Q would be equal to Zn plus 2 ion product. This is our product, this is our reactant. तो ये Q लिखना मैंने सिखाया है यहाँ पर, ठीक है. What is this cell potential? It is actually, this is the total potential developed due to the potential difference between the two electrodes, right? आपका हाफ ऑक्सीडेशन हाफ सेल एंड रिडक्शन half cell, इन दोनों को ऐड कर देंगे, then the new potential, the total potential will be called as cell potential. So standard oxidation potential plus standard reduction potential. So this is the formula. So this is the formula which I can also say. The formula can also be written as, check this out, E cell is equal to SRP cathode, standard reduction potential of cathode, minus, sorry, I'm really sorry, plus standard oxidation potential of anode. One very, very important formula I have just derived in front of you. So I have basically generalized it. Okay? Here cathode was copper plus 2 getting deposited to, getting in, it is becoming from plus 2, it is becoming copper, right? And zinc is becoming from zinc, it is becoming plus 2. जिंक से जिंक प्लस 2 हो रहा है, देख रहा है? ये आपको बातें समझ आ रही हैं आशा करता हूं। तो अगर मैं दिखाऊं ये आपका एनोड, व्हाट इज हैपनिंग है, जिंक is getting converted into zinc plus 2, and your copper, what is happening here, Cu plus 2 is getting deposited as copper, जो मैंने पहले आपको रिप्रेजेंटेशन सिखाया, जस्ट लाइक दैट। ठीक है, ऑलराइट, हमें ये भी समझ आ गया है, ये भी हमें क्लियर हो गया है। अच्छा, मैंने सॉल्ट ब्रिज के बारे में बेटा आपको बताया कि इट मेक्स श्योर the two half cells are complete or internal circuit is complete. Similarly, your salt bridge makes sure electrical neutrality is maintained. And fourth and the last very important point, liquid liquid junction potential को ये eliminate करता है, it eliminates liquid liquid junction potential। यहाँ ध्यान दीजिएगा, very important. By chance if your cell contains Ag plus Hg plus 2 ion, Pb plus 2 ion, then KCl and NaCl are never taken as salts, because, or the salt in the salt bridge, because it can react with it and you will get precipitations, you will get a precipitation reaction. To avoid that, we'll never use these two salts. Okay, so it's a very good tip which you can understand, and logic is I have just now explained. तो कभी भी आपको लिख दिया जाए, the cell is the half cell is coming from Ag plus or Hg or lead ion, do not use KCl and NaCl। all right, ठीक है बच्चों, हमें ये भी समझ आया। अभी क्वेश्चंस बनते हैं कि सेल पोटेंशियल निकाले कैसे, तो वो समझ रहे हैं। ठीक है, तो यहाँ पे इतना क्लियर हो गया है, तो मैंने इसकी डेफिनेशन भी लिख दी है। इट इज द पोटेंशियल डेवलप्ड इन द सेल ड्यू टू द डिफरेंस इन इलेक्ट्रोड पोटेंशियल ऑफ टू हाफ सेल। तो वही टोटल को ऐड कर दो, यू विल गेट द सेल पोटेंशियल। अच्छा, अब देखो एक बड़ा इंपॉर्टेंट नोट, A से gives you A plus 2 electron. Let's say this is an oxidation process. What is happening here? Oxidation. This is called as standard oxidation potential. If I just reverse the process, it will become reduction. And thermodynamics says, beta, according to thermodynamics, if this would have, the sign here is positive, if you reverse the reaction, it becomes negative, right? So if SOP was there, if I reverse the reaction, it will become SRP. Whatever the value was there, just put a negative sign. So SOP is equal to minus of SRP. ठीक है, ये याद करना है, ये बड़ा इंपॉर्टेंट पॉइंट है। Why am I telling you, boys and girls? Because your entire electrochemistry runs on reduction potential. I will give you a cell in which oxidation is happening, but I will give you there purposely standard reduction potential. So better to learn the formula also. There are so many formulae, but I will recommend you learn one formula and follow that, and then everything will, all other formulas you will automatically understand, all other formula you will automatically understand। ठीक है, तो यहाँ पर याद रखना है कि SOP is equal to minus of SRP। ठीक है, जो भी SOP वैल्यू है, just reverse the reaction, the value will become negative, and that will be called as standard reduction potential। ठीक है, अब इसको यूज करते हैं। देखो अभी अभी एक फॉर्मूला पढ़ाया, E naught cell is equal to SOP anode plus SRP cathode। ठीक है, similarly I can write in front in the term of oxidation potential, so SOP anode can also be written as SOP cathode। but boys and girls, all my sailors, most of the questions are given in the form of they're always given in the form of SRP, ज़्यादा से ज़्यादा SRP में मिलते हैं। So why don't we learn this formula, SRP of cathode minus SRP of anode। I will recommend you to learn any one। My personal favorite is this one, my personal favorite is this one। मैं recommend करूंगा ये भी पढ़ लो एक्चुअली। ठीक है, यही याद कर लो, तो इससे आप सेल का पोटेंशियल निकाल सकते हो। अगेन, if everything is taken in standard condition, it will be called as standard cell, E naught cell। ठीक है, अच्छा अब देखो, अब इसकी रिप्रेजेंटेशन पढ़ते हैं। सेल का एक रिप्रेजेंटेशन होता है कि एनोड को हमेशा लेफ्ट में लिखो, कैथोड को हमेशा राइट में लिखो, एंड डबल double vertical lines is an indicator that it is a salt bridge. So you always write your cell in such a manner. By looking at a cell, you will understand which is undergoing oxidation, what is your anode, what is your cathode. यहाँ पर आपको हमेशा लेफ्ट में you have to put anode, on the right side you have to put cathode. This is the rule, right? At anode, what is happening? Oxidation, and at cathode, what is happening? Reduction. You should know that. Acha. And then you will come across some terms as you will proceed in the chapter. If the components are in the same phase, then they are separated by a comma. For example, if I have to represent their electrode potential, I will use Fe plus 2, comma, Fe plus 3. Means oxidation has happened. This is a symbol of OP, oxidation potential. What about SOP? Just put a knot. Just put a knot. I hope you are understanding and you felt like yeah, yaar, samajh aa gaya. Similarly, if the components are in different phase, they are separated by a vertical line. I told you they are separated by a vertical line. And if the entire half cell is changing, it means there must be a salt bridge. Then you put double bonds, double vertical lines. Okay? For example, you check this out. What is happening here? It means this side is anode, this side is cathode. This is the last question which we had done अभी अभी. ठीक है, यही करा था. एनोड मतलब ऑक्सीडेशन क्या होगा बेटा, जिंक से इट इज बिकमिंग जिंक प्लस टू इलेक्ट्रॉन, राइट. व्हाट अबाउट कैथोड बेटा, दिस इज आवर एनोड. एनोड पे हमेशा क्या होगा, एनोड पे हमेशा ऑक्सीडेशन होगा. व्हाट अबाउट कैथोड बॉयज एंड गर्ल्स, इट मींस रिडक्शन. कॉपर प्लस टू इज एक्सेप्टिंग टू इलेक्ट्रॉन्स. यू नो, आई होप इट इज क्लियर. ये आपको सबको समझ आया है, ये सबको क्लियर हुआ है, ठीक है. अच्छा, यहाँ पर हमारे को देखना है, देखो तो कैथोड प्लस टू इलेक्ट्रॉन गिव्स यू कॉपर, रिडक्शन. देखते ही पता लग गया. सो हियर यू आर गेटिंग रिडक्शन, you are getting reduction here and you are getting oxidation here. I hope it is clear. ये सबको समझ आ गया, बहुत इंपॉर्टेंट पॉइंट था. अच्छा, now you see another thing here. देखो zinc plus 2 is in aqueous form. Underneath it you can write its concentration. Underneath it you can write its concentration. If there is a gas, we can write its pressure also. And I'm writing aqueous to represent it is in aqueous phase. I'm writing solid to represent it is in solid phase. Vertical line represents ki yes, there is a phase change. Double vertical lines represent that there is a salt bridge. On the left side you will put anode, on the right side you will put cathode. I hope boys and girls ये आपको समझ आ गया. ये बहुत आसान है, बहुत इंपॉर्टेंट है. ठीक है, तो एक क्वेश्चन आप लोगों के लिए दे दिया मैंने. प्लीज डू चेक योर नॉलेज. एवरीवन विल चेक देयर नॉलेज. देखो, तो आपको यहाँ पे क्वेश्चन करना है, राइट द नेट सेल रिएक्शन फॉर अ गिवन एक्सप्रेशन. इट मींस दिस मस्ट बी एक्टिंग एज एनोड and this must be acting as cathode. ठीक है, check out, it is asking you to remove 3 electrons. So A is giving you A plus 3 electron, whereas B is accepting only 2 electrons. So we'll write that only. Correct, it will become B. You have to pause, so please pause kar do. If you had to, if you are doing it, please pause the video and find your answer. Still you have time. ठीक है, find your answer. अच्छा, now check this out. ये भी हो गया. But beta, the electrons are not balanced. So what I have to do, I have to multiply the equation. I'm multiplying here by 2, multiplying here by 3. So at the end, what I will get, I'll get 2a plus 3b plus 2 ion gives you 2a plus 3 ion and 3b. Correct? I hope it is clear. The electrons will get cancelled like this. You have to make sure that the total number of electrons are same in a process. They get cancelled out. How many electrons are involved? If I ask, 6 electrons are involved. If I ask you how many, 6. ठीक है, ये भी समझ आया. तो हमने आपको पूरा लिख के दिखा दिया. Can you guys tell me quickly what will be the Q of it? What will be the Q of this reaction? Q would be equal to, this is aqueous, this is aqueous, this is solid, this is solid. तो Q क्या हो जाएगा बेटा? Q would be product concentration A plus 3 की power 2 divided by B plus 2 की power 3, right? That will be our Q. I hope it is clear. ये आपको Q लिखना आ गया है. I hope it is clear. सबका यही लिख के आया होगा आशा करता हूँ. Similarly, why I'm not writing A and B? Because they are solids, right? An activity of solid is 1. अच्छा, ये भी क्लियर हुआ. अब बेटा सेल पोटेंशियल निकालना है. तो देखो अगर ये है तो ये आपका किसकी तरह हो रहा है, ये आपका एनोड की तरह काम कर रहा है. इट मस्ट बी अंडरगोइंग ऑक्सीडेशन. दिस इज एक्टिंग एज कैथोड. This B part is acting as cathode. But boys and girls, to our surprise, they have only mentioned oxidation potential. So you have a choice here. It's a very, very good question. Both of these potential, you notice, from 0 it is becoming plus 3, means it is oxidation is happening. From 0 it is becoming plus 2, means oxidation is happening. It is not a data of reduction potential. What happens in reduction potential? You get metal from plus n state to m, or from higher state it is becoming 0, it means it is reduction. All of these are oxidation potential. So you can use SOP formula if you want to, or you can also modify the formula just like I have done. Check this out. What I have done here, boys and girls, check this out. E naught cell मैंने कैसे निकाला, देखो बड़ा आराम से निकाला. What is the formula I have used? I have used the formula SOP. You know your values are right here. Check this out. I have used the formula SOP anode, and since it was plus SRP cathode, it will become minus SOP cathode. You can modify like this. You can use this formula for E naught cell, or you can also be smart. You can also use SRP of cathode. You can also use that. Doesn't matter. Minus SOP. Oh, sorry. SRP of anode. आप ये भी इस्तेमाल कर सकते थे. Now what you have to do here? You have to just convert the values. Cathode value is given to you, beta, is what? 1 volt. I will use minus 1. Anode value was given as plus 4. I will use minus 4. So what is the overall answer? It is coming again 3 ना. यहाँ पे भी तो answer 3 आ रहा है, 3 volt. Answer would be same. Any formula you use, your choice. Any formula you use, your choice. ठीक है. और देखो मैंने ये सब कुछ बनाया है, सब कुछ किया है. ठीक है, आपके सामने किया था. अच्छा. In this particular question, I had also given you concentration. Check this out. So reaction question was given. Can't I find the answer? So A will be 0.1 whole power 2 divided by 0.1 whole power 3. Yes, यही किया है. देख लीजिए आंसर आ गया 0.1. आई होप इट इज क्लियर. सबको समझ आ गया है. तो बेटा अगर आपको ये समझ आ रहा है, क्लियर हो रहा है, तो आई वुड रिकमेंड कि अगर आपको और अच्छे से पढ़ना है, इफ यू वांट टू लर्न in every day, because COVID-19 is out there, we are not learning every day, we are procrastinating. This crash course will make sure you become regular, you become attentive, you have a proper schedule, you will be learning from us, doubts will be clarified, your content you will be getting, study material you will be getting, and yes, we have test series also. What is the advantage of this test series, boys and girls? Pay full attention to this point. Not only you will give tests, you will be also analyzed as compared to your your classmates. As a result, a competitive feeling would be coming out. You will be getting what is your all India rank. This kind of feedbacks will be given to you, and you will be always attentive. Okay, I need to improve myself, I need to work somewhere, right? So automatically you will get these points. If you buy any other test series right now, you will just be solving the papers. You will not be analyzing where you stand. So this particular thing can happen only with this JEE crash course. It is starting. It has actually started, but you haven't missed many things. You will get all the recordings. You will get everything when you will join this. ठीक है? तो जल्दी से join करो and be continuous. Procrastination छोड़ दो. It will make you regular because your D day has been shifted. It will make sure that you guys are learning with a smile, and every day you are working hard and learning something new, and it will make you continuous, in my personal humble opinion. And best part, bachcho, if you will use my coupon code, that is HMCC, if you will use this coupon code beta, it will give you a heavy discount. This particular thing was of 25,000. But if you will use my coupon code beta, you will get it at a very nice price, that is of 6,000 rupees. If you will apply the coupon code, okay, make sure you do. It will be very, very beneficial for you. And yes, you will be continuous and you will learn, you will get content, you will get discussion, live discussion, test clearance test also we discussed. And yes, best part, you can analyze where you stand and you can always improve, okay, and you will become continuous. COVID-19 has hampered with us थोड़ा सा ये तो मानना पड़ेगा. But Vedantu is making sure your studies do not get hampered. So boys and girls, thank you so much. I hope you have liked the video, and yes, please make sure you join our Telegram group because we are posting assignments. I'm going to post up assignment for this chapter very soon, so make sure you be there and solve it with me. And yes, thank you so much. If you have loved the video, please make sure you like, share, and subscribe. That's it for me today. See you next time. Thank you so much.